Hello viewer, how are you? Hi, I'm Shriya. Welcome to Experience Learning. Hope you are doing well. Today we are going to discuss another MCQs tricks and this will be helpful for your exam like GATE, NET, SET, ISRO, whatever any other competitive exam. And today's topic is binary tree and binary search tree, and it will be discussed in two consecutive videos. You can click on the I button and see the next video. And before going to discuss about it, I just want to tell you about the course that binary tree and binary search tree and some important formulas of binary tree and binary search tree will be discussed here. And the MCQs which are very frequent in the competitive exam, you can see, you can easily solve this from these formulas. Okay, let's start. And before going to start it, I would like to request you, please subscribe the channel and press the bell icon. Actually, your subscription motivates me to create more and more this kind of video. Okay, let's start. So we know about linear data structure like array, linked list, or stack, queue, whatever. Now we are going to discuss about the non-linear data structure. And tree is one of the example of non-linear data structure. So what is tree? First we know about it that this one is a non-linear data structure, and here the data are stored in the hierarchical order. So what is this? Think about the situation. In your laptop or whatever, in your desktop, you have one D drive, say D drive, and in this D drive we have three folders: folder 1, folder 2, folder 3. And in folder 1 you have three other folders or two other folder, 1.1, 1.2, and folder 3 has 3.1, and then we have the file, and folder 2 have two files. Folder 1 have one file, folder 2 have two files, like this. Okay, so this is basically the tree structure, where you can consider D as root, doesn't have any parent, and the file cannot have any other thing. So these are the leaf. So this file you can consider it as leaf, and these are the internal node. I hope you can understand. So one node which doesn't have any parent, this one will be considered as root node, and this file doesn't have any child, so you can consider it as leaf node. So if I draw the structure in such a way, okay, say A, if I draw this, so this is the tree where A is root, doesn't have any parent, and F1, F2, these are the leaf node which doesn't have any child. These are known as leaf node, and in between these, sorry, C is also the leaf node, D, B, F, these are the internal node. This is a definition of tree. Hope you can understand it. So we have already discussed about what is tree. Now we are going to discuss what is binary tree. I have already discussed it, the traversal of tree and all. You can click on the I button and you can see it. Okay, still I am going to discuss about it. What is binary tree? The binary tree is a kind of tree where a node have at most two children, at most. So this is binary tree. Binary tree, you can consider it as binary tree, doesn't have any child, and this one is also the binary tree. So at most 2 children will be there. Now I am going to write some property of the binary tree, and then I will discuss it one by one. Okay, these are the properties of some properties of binary tree. Please remember it, but no need to memorize. I mean, ratta marne ki zarurat nahi. But see this property, we will explain one by one, and I think you will get some MCQs from this. I mean, if you can remember this formulas, you can easily solve the MCQs. Now see, what is given? First one, any binary tree, the maximum number of nodes on level A is 2 to the power L, where L greater or equals to 0. Now see, if I draw the tree, this is also a binary tree, isn't it? And if I draw, see here the maximum number of nodes, okay? If I draw now, this is level 0. Level 0. Root level is always 0, remember. The root level is always 0, and then it will be increased. Level 1. Here it is level 1. And in that case, it is level 0, level 1, level 2. Okay. L0, L1, L2. Now, 2 to the power level, here L is 0, 2 to the power 0. We know that anything to the power 0 equals to 1. So here how many numbers of node we have? Level 0, 1. So maximum number of node possible in level 0 is 1. Now see, when 2 to the power 1, level 1. See, 2 to the power 1 means 2. Maximum number of node possible in level 1, 2. If it is 2 to the power 2, 0, 1, 2. Maximum number of node possible in level 2, 4. Okay. So, no need to remember this. I think you can easily see this, easily remember this example, and from where you can just derive this. So 2 to the power L is where L is the level, and the maximum number of nodes possible in level L is 2 to the power L. Now the next one is given as the maximum number of nodes possible in a binary tree, total number of nodes. This question was the level. Now the total number of nodes, maximum node possible of height h. Now what is height? Height is the maximum number of nodes possible in a path. What is path? Path is the consecutive edge. Sequence of consecutive edge is known as path. So that is, if I draw this, so you can say that from, I am giving the value 1, 2, 3, 4, 5. Say I am giving the level of this. So 1 to 2, 2 to 3, 3 to 4. This is one path. 1 to 2, 2 to 5, another path. This one is known as path. Now, what is here? Height is the maximum number of node possible in a path starting from root to leaf. Starting from root to leaf, the maximum level of this leaf. So, height of the tree is 1, 2, 3, 4. Okay. You can also think it in this way, say level 0, level 1, level 2, level 3, level 4. Okay, so I have missed it, sorry. L0, L1, here it is L2 and it is L3. So what will be the height of the tree? Height of the tree is 1, 2, 3, 4 because the maximum number of node possible from root to leaf 4 and level is 3. So from here we can write L equals to L max, H equals to L max plus 1, isn't it? Maximum level plus 1 is height. Please remember this. Okay, now if you want to derive this, so maximum number of node possible, two to the power L, sum of 2 to the power L, and L will be from 0 to L max. So here I can write it 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power L max, isn't it? And if I apply the GP formula, then it will be 2 to the power L max plus 1, isn't it? Because total number of terms is L max plus 1 because it is started from 0, not from 1. So from 0 to L max, the total number of terms is L max plus 1 minus 1, 2 minus 1. So here it is the total number of node possible n equals to, so I am thinking that the total number of node equals to n equals to 2 to the power L max plus 1 minus 1. So we also know that H equals to L max plus 1. So from here I can easily write 2 to the power H minus 1. Okay. From this formula you can also get another one. So here the maximum number of node possible is n, isn't it? Maximum number of node possible is n. So I can write it as n less or equals to 2 to the power h minus 1. Now n plus 1 equals to, if I want to equate it, 2 to the power h. Apply log in both sides. So log n plus 1 equals to log 2 to the power 2 base 2 to the power h. Log base 2. Now it will be log 2 n plus 1, log 2 base 2, and here the h will be here, and we know that log 2 base 2 is 1, so here h into 1, isn't it? 2 to the power h will be h into log 2 base 2, now h into 1. As we know, the relation was initially this one, so here it will be. So if the height is given and you have to find out the number of node, or the number of nodes is given, you have to find out the height, you can easily do this using this formulas. Remember both of this, or no need to remember both of this, you can remember only one and other can be derived easily. Okay. Okay, now the third one. For any non-empty tree, if n0 is the number of leaf nodes, that means degree 0, and n2 is the number of internal nodes of degree 2, then n0 equals to n2 plus 1. Okay. What is degree? The number of children of a node is known as degree. What will be the degree of it? Say I am giving the level 1, 2, 3. The degree of 1 is 2. The degree of 2 is 0. Degree of 3 is 0. If I draw this one, say 4, the degree of 3 will be now 1. And degree of 4 is 0. In this way. So degree is the number of children of a node. Now, we know the formula that the number of age in a tree is, if n is the number of node, the number of age will be n minus 1. E is the age will be n minus 1. See here the number of node 1, 2, 3, 4, 5 and age 1, 2, 3, 4. So, n minus 1 equals to E, or you can write it n equals to E plus 1. Now, the number of ages E, I can represent it first represent that n equals to total number of node, and the total number of node can be written in such a way n0 having no children. So this is the number of leaf plus n1 plus n2. What is n1? Having at least one child, like this node, and here this is the degree of the node where it has 2 children. Now, E can be represented as, see, n0 having no children, so 0 into n0, plus having 1 into n1, having 2 into n2. The age can be represented in this way. Why? Because n2 is the number of nodes having 2 children. So here obviously the age will be 2 into the number of nodes, isn't it? And here the number of age will be at least one child, one child. So degree is 1. So age will be 1 into n1 nodes having one child. So the age will be 1 into n1 in this way. So from here I can write it equals to n1 plus 2 n2. And now I am going to write it n equals to E plus 1. We know this. And n will be written, I am again writing it n0 plus n1 plus n2 equals to this one, n1 plus 2 n2 plus 1. Can I write it? Now see, n1, it is 1 into 2 n2, so n0 will be minus, so n2 plus 2. Okay. So now you know that how we are getting this n0 equals to n2 plus 1. Just remember that n1 equals to e plus 1, n equals to e plus 1, and remember this representation. No need to remember it actually, you can see this. n0 having n0, say here the degree is n0. No age from this child. And now if we have n1, so total number of n1 is here 1, 2. So number of age possible here 1, 2. So number of node 2, age possible 1 into 2. In this way you can actually say this. Okay, here the question is given. The binary tree of number of internal nodes of degree 1 is 5 and the number of internal nodes of degree 2 is 10. So the number of leaf nodes, you have to find out the number of leaf nodes Now, maybe you will be confused with this data, but here the examiner is just given you to make you confused about it. Don't be confused because you know the formula. What is the formula? N0 equals to N2 plus 1, isn't it? So, number of leaf node will be degree 2 node is 10 plus 1. This is the number of leaf node. So, here it will be this one. Okay. But remember, if the question is given the total number of nodes, then you have to consider all of this. Number of leaf nodes, number of nodes degree 2 and then degree 1. If the question is given that you have to find out the total number of nodes in the binary tree, then you have to also consider this one. Okay, this question is given that the maximum depth of binary tree with n nodes. What will be the maximum depth? Depth or height is same. Remember that depth and height is same. We know that what is the height of this tree? The maximum number of possible nodes is 2. Now, if I draw this in this way, that means every level there will be only one nodes. So that time we can reach the maximum level, isn't it? So here the answer will be this one, n. If I place one node in each level, you can write it, you can draw this in this way or this way also. These are known as skewed binary tree. These are known as skewed binary tree. One is right skewed and another one is left skewed. So in case of skewed binary tree, we can place one node in each level. That means the depth will be maximum depth having n, it will be n. If I draw this tree in this way, here the number of nodes you can see is 1, 2, 3, 4. Number of nodes is 4, but the depth is 3. But this is not the maximum depth we can reach using this 1, 2, 3, 4 nodes. So if I want to reach the maximum depth, we can place it in this way. You can give the question can be given in another way also, that is the minimum number of nodes in height h. You can get this question also, the minimum number of nodes in height h. Obviously the answer will be h number of nodes. So remember this, the question can be given in any way. Okay. Okay, thank you. And one thing, the binary search tree, I am going to discuss about it in next video. Please click on the I button. Okay.